All right, so section 4.1, the vertex form of a quadratic function. So this section requires a lot of prerequisite work. I got to define stuff for you, okay? Once we define it, graphing these things is pretty easy once we know what means what. But we first have to figure out, what is my vertex? Which way is it shifting, up or down? Or they call it translating, but which way is it shifting and stuff like that. So I have to define all that. So that's going to be like the meat of the actual lesson is the definitions. Okay. So let me write that down for us over here. Okay. So vertex form for quadratics. Now we've already kind of seen this before, okay? If I can remind you, you guys remember when we did examples that look like this? When we were graphing absolute value inequality, equations, I mean, right? And they look like the letter V, right? We used that formula, okay, way back then. So now we're actually going to use a formula that looks like this. Y equals a times x minus h squared plus k. Notice the similarities, okay? The only main difference is that one of them has an absolute value, the one on the right. The one on the left has something in a parenthesis squared, right? The squared term creates the quadratic, right? The U shape, right? The parabola. But notice there is a similarity between what we did, I don't even know how long it's been, maybe 3 weeks ago, and what we're going to do today. Okay? So this was just a real quick, I'll put it right here, just a recall. Okay? Just remember that we did this before. So for quadratics, here's what we know. A is the amplitude. Now with the one in green, remember we called it the slope, right? That's how many times you went up and over, up and over. It's not so much the slope on quadratics, okay? Kind of is, but it really isn't, okay? So it's the amplitude. That's what stretches your graph like up and makes it kind of like a little thinner, or else it pushes it down and it makes it wider. So they call it a vertical stretch or a vertical shrink. I usually don't like to use those terms because I honestly get them confused all the time. Like if I get a graph and I make it thinner, is that a shrink or is that a stretch? Like what am I doing? Am I stretching it or am I shrinking it, right? Like I guess it depends on which way I'm looking at it, right? So it's always confusing. So I've never really liked testing people on, is this a vertical stretch or is this a vertical shrink, right? It can mean different things for different people. So I'm not too worried about that. We'll just call it the amplitude, okay? That's how fast the parabola grows. So it can go up really fast or really slow, so it gets kind of wider. Okay, so that's our amplitude. Now, h comma k is still our vertex. Okay, it's still going to be the same thing. All right, and just like we did before, I'm going to kind of talk a little bit about h right now. So h, this is your horizontal shift. Okay, this is your horizontal shift. You're going to move left or right based on h. Now, if h looks, I don't know if you guys remember this, but I told you guys that h always lies to you. If it says -2, that really is a +2 where the h is. If the h says a +5, it really means -5. It always lies to you. So it looks different, right? So if h looks positive, move left h times. So if h looks positive, move left. Okay? And if h looks negative, you're going to move right. h times. I mean, this is the key to doing most of these graphs, so I hope you guys don't mind all this writing, but it's going to be the real reason why we can graph these things so quickly. Okay? So that's our h term. Now, our k term is our vertical shift. Okay? And that tells us whether we move up or down. So let me go ahead and write that down here. Our k term. This is our vertical shift. So if k is positive, so it doesn't matter if it looks positive, that means it is positive. K never lies to you. It doesn't try to tell you something that it's not. So if k is positive, move up k times. And if k is negative, move down k times. Now I know you guys are writing this down right now, but give me a second. I just want to try to find this for you guys here. I think it was chapter 2, section 2.5. Look at this. You guys see the similarity? H, K, right? It moves left, right, up, down. A is your amplitude. Only we called it a slope here. We're not going to call it a slope with the parabola. Okay? But there's a similarity there. Okay, and then notice a little bit lower. HK is my vertex. Right? So it's the same thing that we did in section 2.5. It has a different equation. Okay? So, but it's the same definitions. Okay, you can see them right here. Amplitude, vertex, horizontal shift, vertical shift. So hopefully this you kind of recall it and it doesn't cause any issues. Okay, hopefully you have a easy time with it. So, all right, now that we have all those definitions, let me look at this. You have 1, 2, 3, 4, 5, 6, 7, 8, 8 graphing problems. So we'll pick a couple of them. Oh, and actually, there is one thing I forgot to mention. Let me put it up here with amplitude. A negative A opens down. A positive A opens up. I forgot to list that for you guys, so go ahead and write that down. So if it's a negative A, it's going to open down. So it's going to be like a upside down U. If it's a positive A, it's going to open up. So like I said, we have 8 graphing problems. We'll try doing 3 of them. Okay, you'll see they're not that hard to do. Okay, we'll try doing 3 of them. And then after that, we'll switch over to the translation stuff that they want you guys to be able to do as well. Okay, but knowing this is the most important part. Okay, left, right movement, up and down movement, and your A term opening up or down. So let me find the first problem here for us to do. Let's take a look at number 2. Okay, so number 2, it's 2 times x plus 3 squared minus 4. So I'm going to do it right here under the notes here, okay? This is number 2. Y equals 2 times, let me see if I'm right, x plus 3. Yeah, x plus 3 squared minus 4. And they want me to graph it. So I'm going to graph this thing. I want you to note, I am not really going to create a table. I know a lot of times teachers are like, okay, create a table and calculate 5 different numbers. I mean, you can do that if you want to, okay? I've never been a big fan of it because all you're really trying to do is sketch this right, okay? You're just trying to sketch this right. So, maybe I might make a table at first to show you something, a little trick, and then from there we won't do it anymore, okay? So, first off, where is my vertex for this problem? Can anybody tell me that? My HK. All right, so half right. Remember that the H likes to lie to you, so it's not really a 3. It's a negative 3, right? The number inside the parenthesis always is opposite of what you see, right? So it's going to be negative 3, negative 4, okay? Which I may have to actually, well, I guess I can do that. That's fine. Negative 3, negative 4. So I'm going to go ahead and put that right here. There's my point, negative 3, negative 4. I'll put that point there for us, okay? Negative 3, negative 4. Which way is this supposed to open? Up, right? Because it's a positive 2. Notice A equals 2. I'm just going to put right here, up. Okay? Now, like I told you, I'm going to make a table just this once, just to try to show something to you guys. X, Y. I'm going to pick 3 points. But one of them is going to be my vertex, which I already solved for. Okay? In the middle, I'm going to put my vertex. So I'm going to pick a number smaller than negative 3 for x and a number bigger than negative 3 for x. So I'm going to try negative 4 and negative 2. Okay? And I'm going to plug it into my equation. Again, you guys don't have to do this all the time. I want you guys to notice something about the way the points land. But let's plug it into my equation. So y equals 2 times, I'm going to plug in a negative 2 first. Negative 2 plus 3 squared minus 4. All right, let me simplify. Negative 2 plus 3 is 1. 1 squared is 1, and 1 times 2 is 2. So my solution is 2 minus 4. So this would be negative 2. What do we know about parabolas? If I find a number on the right side, doesn't it copy itself on the left side as well? Right? They're symmetric, right? They kind of have the same numbers. They have the same look. So, if I were to plug in a negative 4, I should expect to get a negative 2. Now, I'm just going to do it once, like I said, just to kind of prove it to you guys. But then we're going to talk a little bit about what we see. So, let me show you that negative 4 will come out to basically the same thing. So y equals to 2 times negative 4 plus 3 squared minus 4. Negative 4 plus 3 is a negative 1. So 2 times negative 1 squared minus 4. Negative 1 squared is 1. And 1 times 2 is 2. 2 minus 4 is negative 2. Okay? So let me graph these, and then I'm going to show you the thing I want you to see. I'm going to graph these points here. Negative 4, negative 2, negative 2, negative 2. Okay? So there they are. Now, notice something, guys. How many times do I go up and over? From the red dot to a purple one. How many times do I go up? Let me zoom in. To go from the red dot to the purple dot, how many times do I go up? All right, 2. Thank you. How many times over? Just once. So 2 over 1, right? What was my A term? My A term was 2 over 1, right? So you can use your A term to figure out your first 2 terms. And once you have those first 2 terms, you can just kind of draw your parabola. And you're done. So notice, do I need to calculate all of these other points right here I really don't. Because if I know A, then from this point, negative 3, 4, I can go from the red dot to where the purple ones ended up by just going up twice, once over. And then you do the same thing the other way, right? Up twice, once over. So I don't actually need to calculate any of this stuff. It's not necessary. Now, what you don't want to do is apply that again, because if you apply that slope one more time, then your next point would be 2 up, 1 over here, and then it's going to look like a straight line, not a curve, okay? You only do that with absolute value functions. You don't do that with quadratics, okay? So that's why I didn't want to call a slope, because it's not really a slope, but it does help you find your first 2 points, okay? So do we have to make a chart? No, we don't have to make a chart. Okay, just use A. So let me show you how to just use A, and you'll see the next problem is way faster. Okay, our next problem is going to be way faster because we don't have to do any calculations. So that's that little trick I wanted to show you guys. So let's see. We'll go over question 3 just because it's positive. I don't want to change it up too much, and then we'll do like question 4. Okay. So let's see. Question number 3, 2 times x minus 4 squared plus 1. So let me put it right here. Number 3, y equals 2 times x minus 4 squared plus 1. Now I'm going to graph this. So again, I'm trying to show you these little shortcuts because a lot of times, I mean, I don't know if you guys agree with me, but graphing can be something that takes a long time to do, right? It may not be hard to do sometimes, but it can take a long time to do everything involved, right? So I'm trying to show you guys some little tips that I've learned over the years of doing this stuff that can help you. And not just show you the trick, but explain to you guys why it works, right? Because it's one thing when a teacher teaches you a trick and you learn it, but you don't even know why you're doing it, right? I'm trying to kind of show you guys, like, this is what I did, and I learned it like this, and this is why it makes sense, okay? So you'll notice I'm making this graph kind of big on purpose because I'm not really sure where this is going to end up, but we'll figure it out. All right, what's my vertex for this one? What's my HK? Remember, your H is a liar, so what's my HK? 4, 1. Thank you. So 4, 1. Let me go to 4, 1. That's right here. 4, 1. Okay, which way does this open, by the way? Up, right? A is 2, right? My A is 2, so it opens up. So all I have to do is go up twice, over once. So here we go. Up twice, so that's 1, 2, over once right here. And up 2 over once right there. And that's it, guys. We're done. I mean, that's fast, right? That doesn't take very long. It took me longer to draw the graph, like the coordinate plane, not even the graph. The background picture took me longer. Okay? If you know how to use the pieces of the formula, graphing is simple. It's when you don't have an understanding of what you're doing, and then you're like, well, I guess I'll make a table with 20 points, and I'll calculate all 20, right? And then you spend 15 minutes drawing one picture. That's not what we want, okay? Let me do one that's negative. I told you number 4. We'll work on number 4. But notice, that was quick. That's why I don't want to do too many of these for you guys, because I'm like, these are easy. You just have to understand how to do them. So I want to do at least 3 of them. So y equals negative 4, x minus 2 squared plus 4. So y equals negative 4, x minus 2 squared plus 4. All right, I'm going to make another graph. Kind of big because I don't know how much I'm going to extend these things out. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is almost a 9 by 9. It's actually a 9 by 10. It might be too big for the equation, but I mean, at least I have enough room to finish it off. So, what is my vertex here? Positive 2, 4. Good. Positive 2, 4. Now, let me put that on the graph. 2, 4, right here. Okay? Now, notice how my A term is a negative 4. Which way does it open? Down, okay? So I know this is opening downwards. It's still going to look like an A. So that means that my A term, that minus 4, or the 4, I'm going to count 4 down and once over, okay? 4 down, so 1, 2, 3, 4, once over. So that's going to be right here. And right here as well. Okay, I'll kind of zoom in for you guys. 4 down and once over. So let me go ahead and draw the graph. Notice how this one's a pretty thin picture, right? Compared to some of the first ones that we did. So there you go. So I mean, I hope you guys can agree with me. Drawing these pictures does not take long, and even faster for you guys because they're going to give you 4 options. You just got to look at which one it is that's right. You're going to look for which one has the right vertex, which one's going the right way, and just check the first 2 points, right? Down 4, over 1, which one matches up, and then you're done. It can be a lot faster. Okay? Now, let me zoom out really quick so I can show you 2 graphs at once. All right, so let's look at question number 3 really quick. You see how question number 3 opens up? That means I can call my vertex, this point, a minimum, a low point. Okay? So my HK is a minimum because it's at the lowest point of the graph. So what do you think I'd call this one? The HK for this one? A maximum, right? That would be a high point, right, on the graph. My vertex would be a maximum. So I'm going to kind of write that for us right here because they're going to ask you that in a couple questions. Is it a minimum or is it a maximum? Okay, so that vertex on the bottom is a maximum. It's the highest point on the graph. Whereas for number 3, it's going to be a minimum. Okay, so for question number 4, they're not asking you this on question 4, just so you know, but they're going to ask us that coming up right now. It's a maximum because it's the highest point. For question number 3 would be a minimum because the vertex is the lowest point. Now, just out of curiosity, question number 1, is that a maximum or a minimum for the vertex? For question 2. It's all the way at the bottom, so we call it minimum, right? Minimum. So something like that would be a minimum. If it's all the way at the top, a maximum. Okay? So why do I tell you this? Well, like I said, let's look at the other homework problems that they're going to give us. And right now we'll get to these 9, 10, 11, 12. We'll get to those right now. Okay? But look at number 16. Then they say, is it a maximum or a minimum? Which way is this graph opening, up or down? What's my A term? It's a positive 1. Positive 1. So which way does it open? Up, right? I don't know what the graph looks like, but it's going to look like that, right? It's going to open up. So that means the vertex would be down here. So that makes it a minimum, right? If right here they had a negative number, then it would open downwards, which gives it a high point. So that gives us a maximum, okay? Now, if you're not sure about it, go ahead and graph it. Just graph it so you can see, right? You don't have to graph it perfectly, but give yourself a little picture, and that should be good, okay? Number 15 just asks you what's the vertex. You guys should be able to do that, right? Just look at your HK, right? Now, axis of symmetry is something that I kind of have to tell you guys about, but it's not that hard. Ready? And this will be in your notes. Axis of symmetry. That's your axis of symmetry. X equals H. So, H is here and here. So let's do number 14 really quick. In a couple seconds, we'll do it. What's my H value for number 14? 13. That's my answer. Okay? What's my H value for this one right here? -3. So C is my answer. Right? That's pretty easy. Just look for your H value. Okay? So here's the last thing. So we'll kind of go over one of these just so you can kind of see it. Let's look at 10. Okay? What they want you to do is to write an equation. Okay? Write it. Well, they're not putting it, but in vertex form. Okay? Assume that A equals 1, they tell you. Okay? So, if they tell you this equation here tells you to move 5 to the right and 6 up, is it true or false? So let's see. 6 up plus 6. Is that true? Yeah, positive 6 means to go up 6 times. 5 right. In order to go 5 right, I need to get a -5 in the H position. That's not true. Right? It says +5. Right? Let me just remind you. For horizontal, I got to move up a little bit. For horizontal movement, to move right, it has to look negative. To move right, it has to look negative. Look at my problem number 10. It has to look negative. Does that look negative? No, that looks positive. So this is false. Okay? The vertical part was right. 6 up plus 6, perfect. But this should look negative in order for me to move right. It should look positive if I'm going to the left. Let's just do one more real quick. What do you guys think? Number 12. 50 down. Does that make sense? Yes. 12 right. To move right, it should look negative. There it is. -12. Right? It should look negative, and it's going to move to the right. This is a true statement. Okay? So that's a true. So for these problems, you're going to have to use that list of stuff that I gave you. Okay? But that's what your homework's going to be, guys.